Hello guys, we have developed a project. It's nothing but smart system for attendance using facenet, where where my teammates are Rakil, Sandhya, and Mans and Stravani. We have developed this system. It can recognize 70 images in a snapshot, where we can increase the training size. Then the increasing capacity of the testing size will be high. Whereas here I am going to take a small part of my introduction. Traditionally, attendance is masked manually by teachers, where here there are so many losses, like the time is wasted as well as the paper which we are using is wasted, and there are some misconceptions and there are some proxy cases where we had been overcome these by using these kinds of technical systems, where we can, in order to we can determine this classroom attendance by using face detection and face recognition, where we will perform this model, where we had used some deep learning algorithms. In classroom we need to extract an image from the image. We are going to get the sub images of the face directly by using some MTCN and other algorithms which we had used in it, where these are the significance which I am talking about. It's automated, economical, efficient, and keep extra time. It's nothing but we are going to save some time. Here the basic structure goes on, where there is a high definition camera on the board of the top, where the students will be focused. Generally when we go into any project, they'll ask how much distance will be there. It depends upon the classroom ecosystem, where the lighting conditions, where we need to focus on each face, where the face should be clear. That's the thing. It's nothing but 20 feet or 30 feet or these kinds of situations, where here you can see we can recognize these faces. And here the database goes on. This is the process which we are going on, and the image process is this. Whereas there are some networks, there will say face vectors, where ResNet going to choose the face vectors. So for each and every face we are going to get these vectors, and as well as we are going to get the probability of the each model by using MTCNN, where I'll show the MTCN output as well, where we have used Inception ResNet V1, which was an integrated model as a hybrid model, which has been trained with VGG phase 2, where Inception ResNet is an hybrid network model, which was an overall performance is nice, where the both correlated and trained with VGG phase 2 will call as a Google Net, where the MTCN based recognition will be as this, and some of the vectors will be generated. There will be a vector field. I'll show in the next parts of the slide. Here the database is stored in likewise of this manner, where you can see. And for each people, let me consider this 527. Okay, here you can see the images are given in a numerical form. And okay, then fine, next we are going to here and thereafter, here you can see the identification will be done, and our future work is also provided here, where you can take a snapshot of it. And now I'll go to the live implementation which we have done. Now for getting the embeddings, as I told, we need to get the face vectors, we need to get the embeddings. I am going to run this program. So here you can see there are some face detected probabilities which will be getting as soon as when the program has been executed. These are the face probabilities. By using these face probabilities, we are going to get the face vectors, how many vectors we have. Yes guys, now you can see the program has been completely executed. Here you can find the probability vectors of the each person, which we can see, and thereafter we are going to get the embeddings and run the model. Thereafter I am going to give an image. We are going to get a GUI output of this, where the GUI outputs is like this. We are going to browse and give the complete image of the class. I am going to upload a test2 file, and after pressing OK, we are going to get the output of the image. See here you can see where I had told this 527, the improvement of the algorithm which we had used and the model which he has. Here you can find he was not wearing any kind of spectacles, but when you will see the output image as the testing image, he has spectacles. So it has detected, because we are using vectors, we are not using any face mapping algorithms here, and therefore